We are assuming that IQ scores for adults in America are normally distributed with a standard deviation of 15 and a mean of 100. If we select one adult at random, what's the probability that his or her IQ score is more than 105? And if we happen to take a sample of 50 American adults, what's the probability that their average IQ score is more than 105? So the information from the problem, we're given the standard deviation, which we call our sigma, that is equal to 15, and then our mean, which is equal to 100, and we know that we have a normal distribution. So if we want to find the probability that a single person has an IQ score of more than 105, we write that as the probability that x is greater than 105. And what we want to do is turn this into a standard normal, which we call a z, to look it up in our table. And we do that by subtracting our mean and dividing by our standard deviation. So if we subtract 100 and divide by 15 everywhere within our inequality statement, what we'll be left with is the probability that z, because x minus mu over sigma is z, is greater than the number 0.33. If we want to look for a greater than statement, we can use a trick that says we look up z less than the negative of our number, and we can go get this from our table. So if we look for a negative 0.33 in our table, that will be found by looking at the 0.03 column on the top, and then we want to look for negative 0.3 on the side. And what we will get is this quantity 0.3707. Now we're going to change the problem slightly because we're still going to look for a score greater than 105, but now we're talking about 50 people being chosen, and their average IQ score is what we're interested in. So when we're talking about an average for a group of people, whereas in the first part we just had one person, we're looking at x bar being greater than 105. And how this changes is when we're talking about x bar, our standard deviation is no longer just sigma, but sigma over the square root of n, where n is the sample size. Here that is equal to 50. So to turn this into a z, to get x bar to a z, we subtract the mean of 100, and now we divide by our standard deviation, which is 15 over the square root of n. So we get greater than 105 minus 100 over 15 divided by square root of 50. And this will now be a z. So we get z greater than, the number here will be 2.36. So this is the same as the probability that z is less than negative 2.36, which we can now look up in our table. And we find that for negative 2.3 with 6, we have this column and this row, we get a probability of 0.0091. So we need to distinguish between whether we are talking about one individual, where we can just divide by sigma, or the average for a group of individuals, like we are here for the 50 Americans, and then we have to divide by sigma over the square root of n when changing our value to a z.